Public versus private. Why do classes need to hide things? Hello there! We're doing our very first Game of Apps YouTube channel giveaway. So you could win either one of these two toques, different styles. This one here is has no fold in it and it's shorter. This one's longer and has this fold in it. They're both embroidered with the Game of Apps logo in our colors right here. So why are we doing this giveaway? Well, shameless plug, we want you to subscribe to our channel and we want you to like this video and put in a comment. So that's how you enter. Subscribe to our channel, like this video, and put in a comment as to why you want to win one of these. You get to choose which one. So if you're selected, then you can tell us which one you want. We will be doing the draw on December 31st, 2020, so at the end of the year. So this will be a nice New Year's present for you. And if you win, we will announce this in this channel, and then we will mail this to you via mail. So if you're watching this after December 31st, 2020, then sorry, we've already given it away. But stick around because we'll have other giveaways throughout the year. So again, subscribe to our channel, like this video, and put in a comment, and you can win one of these. Today's tips and tricks will be talking about public versus private access and why we need it in classes. So let's start off with a diagram. Let's say I have a class here, and this class is part of some online shopping app. So it has a method that allows you to calculate the total price, including GST. Okay, so let's say it has a method. So it returns an int, which is the price in cents. A method called add GST, and it takes in an int let's say the original price. So what'll happen here is, let's say you put in an original price of 100, which is $1, so 100 cents. It'll then return to you 105 because GST is 5%. So with an input of 100, it'll give you back 105. So let's say you input 100, the output here will be 105, which is what we expect, right? So this is the external contract that this module or this box provides. So internally, it might represent, it might have an internal variable called GST rate. And this is set to 1.05. Okay, so it has an internal variable, internal property called GST rate that it uses to calculate your GST. So you give it an input price of 100, original price. It'll multiply that by 1.05, and it'll give you the output 105. So what's the problem with this? This is all. Let's see. There's a few issues. So let's look at one of them. Let's say, because now the external objects have access to both the method and the GST rate. So let's say we have an external entity here. It needs to calculate GST. So it can access this method, but it can also access this. So if you had a malicious object, a malicious actor, they could change your GST. So for example, if someone hacked into your system, they say, I don't want to pay 5%. Let me go and, since I have access to this, let me go and change this to 1.01. So now your app has been hacked. All your inputs now will calculate with only 1% GST. So an input of 100 will now give 101. So that's one problem that we have with GST rate being accessible, because by a malicious actor can now change your internal property, and it'll change all of your calculations. Let's give you another example. Let's say it hasn't been hacked, but you have another actor here, another object that says, hey, I don't want to call add GST. I don't want to call this method. I can already access your GST by accessing this directly. So instead of calling add GST, it just retrieves GST rate and uses it in their own calculations. So it takes GST rate here, and then it uses it for its own calculation. So that's fine. It still works, right? The system still works. But what if, let's say, next year the GST rate changes? So instead of 1.05, it becomes 1.06. So if this second actor is still reading it, it still works, right? So you're saying, then what's the problem with that? So no problem so far. But what if, let's say, so this is version 1.0 of your product. Let's say version 2.0, some senior software developer tells you, hey, you shouldn't be using this. You shouldn't be embedding this, hard coding this into your app. The CRA, Canada Revenue Agency, has a database online where you can retrieve the actual GST rate. So there's an external database that has the GST rate. So instead of hard coding this into your app, why don't you just retrieve it? And the reason this senior software engineer tells you to do that is because next year, when the GST rate changes from 5 to 6%, you actually had to go in and change your code and release a new version of your code to update this internal hard-coded value. So he says, instead of doing that, if you retrieve the rate from the external CRA database, then CRA can change their GST rate as many times as it wants, and you don't have to change your code because you're retrieving it from the outside. So you go ahead and do that. You've changed your code, so now instead of retrieving this, instead of storing this internally, you retrieve it externally. Now what happens? This app now breaks because previously it was reading GST rate here, and now it no longer exists. Okay, so those are a couple of the reasons why you might want to have public and private. So what we're doing here is that we're saying this interface, add GST, this is public, and we want that to be the only public interface that any of your users can access. This GST rate here that we had previously, this is an internal implementation detail. So it should be a black box that your external users know nothing about. If it's a black box, they can't access it. So two things: this malicious actor can no longer change your rate because it can't access it. It only has access to this read-only method. This second object here can no longer retrieve the rate directly. It has to always call this method in order to calculate the GST. This way, it shields them from any implementation changes. So you're able to change from an internal representation to retrieving the rate from an external database, and the external interface doesn't change. Okay, so that's the most important thing between public and private. So you want something public to be your external published interface. This is the way the external entities interact with your module. These are the things they can do. These are the things they can access. Everything else that's implementation detail, you put it in your private portion, and the private portion is basically a black box. They can't access it. They can't see what you're doing, or they shouldn't see what you're doing. So that gives you the freedom to change your implementation. And as long as you maintain the same external interface, all of your users won't have to change their code. All right, so here we have the class dish from our project number 3. the food ordering app. And we have a few public properties, right? Name, description, price and cents, image, resource name. We have our constructor. And then below here, we have some private stuff, 3 private properties and 1 private method. So what is this doing here? The dish class here, when you first create a dish object, it populates its own properties. So it's self-populating. And the way it does that is by using this external library, lorem, to randomly generate a name and a description. And also it uses a math random library to generate a random price between $7.99 and $19.99. Now, all this information here is private or implementation details. So we want to put this in a black box so that the external users will not be able to access it. They won't be able to change it. In fact, ideally, it'd be nice if they can't even see it. But it's all right, they can see it as long as they can't change it or do anything about it. And so that's why we make these private. So external users won't be able to access this. They won't be able to retrieve or modify the max and min price and cents. So that's one example. Another example here is in the menu class, again from our food ordering app. So we have a property here called a menu, which is a hash map or a dictionary of cuisine names to a list of dishes. So basically this would be an array of dish objects that match this particular cuisine. So for example, salad, let's say a salad here. If this were salad, then we would have a number of different salads, spinach salad, Caesar salad. Those would be dishes in this array that would map to salad. So this is a property. Now we've made this property private. The reason we made it private is because we don't want people to be able to change this. So once we've generated the menu, then we want this to be read-only. So the way we've done that is by providing this method, dishes by cuisine, which is basically a read-only method that gives you back the menu. So what this method does is it takes this menu, this private property, and returns it. So it actually returns a copy of this menu. So the menu that was returned to callers of this method, they can change that menu object however they want, but it's not going to change this. So the next time someone calls dishes by cuisine, we'll make another copy of this and return that to them. So this way it protects our internal property from any changes. Only this class is able to change menu. And in fact, in our implementation, which you'll see in our demo, we only ever modify this menu once at the very beginning when it's first created. After that, we don't want to change it anymore. And so we don't change it, and we don't allow any external entities to change it as well. All right, so hopefully that explains to you a little bit about what private and public means. And we'll hope that you start using this in your code. By default best practices, you should always start with making something private. And only once you get to the point where you say, hey, I need to make this accessible externally, then change it to public. But by default, if you're writing any method or property, first start by making it private. And only if you've determined that, yeah, this needs to be accessed outside of this class, then make it public. So it forces you to make that analysis and that determination. All right, that's it for today. Talk to you next time. Bye-bye.